Today let's solve another Leetcode problem, number 39, combination sum. So yeah, I think it is very easy to understand the problem. What it said is, we needed to find a combination of numbers inside a ring, so the sum of them will be target. And for each of the numbers, it can be duplicated. But for the combinations, it cannot. For example, this one, 2, 2, 3, this number 2 can be duplicated. But we cannot have like 3, 2, 2 because it's the same combination. Yeah, if we understand the math definition of the combinations. So how we going to do this problem? Yeah, so we are going to use backtracking with the trimming. Let me first explain it in whiteboard and then go back to the code editor and code it up. And when I go to the whiteboard, let me give you an example of this number, 3, 5, and 7. The target would be 7. So when we are going to do the backtracking problem, the first one is how we are going to define this backtracking function and what variables will be inside and what condition it will return one of the answers, and how should we loop through all the numbers. Yeah, according to the problem, this number 2 or 3, it can be duplicated. So this is the hard part of how we are going to design the loop of the backtracking. So as I said, I will start from number 0. This is a counter, number 0. So if this counter equals to my target number 7, I will return one of my result. Yeah, and here I will put a temporary array. I will name it answer. So inside the answer, if this number equals to 7, the target, I will append the result will append one of my answers. So I will explain it later. So this 0 is index. This means where I will start from. Yeah. So for this index, I need to design an algorithm to include this number 2 every time. Yeah, but for the next one, when I go to number 3, I will include this number 3 every time, but I will not go back. Otherwise, there will be duplicate of combinations. Yeah, now let me loop through the backtracking tree. So first of all, this is our definitions. We have a 0 and an empty array and 0 inside. And then I go backtracking one number by another. I will put a number 2 inside my array, and the counter would be 2 because 0 plus 2 is 2. And when I go through next number, it would be 3 inside the array, and the counter would be 3. Similarly, it would be 5, 5, and 7, 7 here. Yeah, I will not go through each node of them like 3, 5, and 7, but basically it's the same. I will just put 2 as an example here. Yeah. So for the next loop, I will still go start from this number 2. I will put a 2 inside, and the count will be 4. And then I will put a 3 inside, the output, the count would be 5. And then I go to the next index, it is 2, 5, so it's a 7. So my target is 7. When it equals to 7, I will put my numbers inside, so the result will be append this array 2 and 5, and I will have a return. Yeah. Now if it go to the next, it is 2 plus 7, the result is 9. So if it is more than the target, I will just return. Yeah, nothing would happen. And here I will go to the next one. Next one would be 2 and 6. Here would be 3 and 7. When it equal to 7, I will append one of my result. Yeah. When it go to the next one, of course, I know I will go trimming and stop the loop. Yeah. For here, I can still go to another one. If I add another 2 inside, it would be 8, and I just need to return. And for others, yeah, it will always be more than 7. It will be returned. So the final answer would be 2, 5, 2, 2, 2, and here is another 7. Yeah, I got my final answer. Now let me go to the code editor to code it up here. As I said, for backtracking problem, first of all, we need to define the function backtracking. Yeah, you may use a DFS, but I will use backtrack as my function. As I said, first of all, I will have the 3 variables. Yeah, the first variable I will define a count inside, and then it is a temporary answer, and then I will define a index. What I'm going to backtrack, so the backtrack is from 0 and empty array, and the index will start from 0. This is my backtrack. And before that, I will define 2 global variables, result and n. So the result would be an empty array because I wanted to return the result. And this n would be the length of a candidate. Yeah, because I will loop through it. Yeah, candidates. Yeah, candidates. And from here, the backtracking, if we finished our definition of the backtracking, we need to find the conditions. So there are 2 conditions we need to consider. First of all, which condition we need to trim? Yeah, because for this kind of a problem, if we don't trim the tree, it will be time limit exceeded. We have to trim it first. So the conditions is easier. If we finished our design, we need to use the count. If the count is more than target, it means we need to return. We don't need to do anything. Yeah. And if this count equals to the target, if the target is 7, we need to put the answer array inside the result. Yeah. And we can use a return to let it go in quickly. Yeah. And then we need to design our final step. Yeah, this is the hard part of the backtracking. Yeah, so for our problem, we can include this index. So I will use for I in range from the index to this number n. Yeah, so I will, first of all, as I already explained here, I will start from each of the index. And then also, if here is a 2, here index start from 0, here will still start from 0. Yeah, so only in this way, I can have all the unique combinations of numbers as I have explained. Yeah, so for I in range these numbers, I'll just need to use a backtrack. For backtrack variables inside, normally for me, I will design 3 or 4, but no more than 5. Otherwise, it would be too complicated. Yeah. So inside, as I explained, the count should be plus the candidate number. So the candidate's number should be, yeah, candidate's number should be this I, and answers I need to plus the candidate, yeah, the candidate's I, and then here the index would be this index I, because I will start from, for example, it will start from 0. So for the first one, I will start from 0, and the next backtracking it will start from 1, 2, and 3. If this n is 4 for this example, yeah. I think I've basically finished the entire code. So this is the result, put everything inside the result, and backtracking. I've already run my backtracking, and this is the conditions. This will return nothing. Here we'll just append the answer. Here is my backtracking design. Now let me run it to check if it really works. Yeah, as you can see, it works. Now let me submit it to check the speed of the algorithm. Yeah, as you can see, it really works. It beats 76% of all, of all Python submissions. Now let me go back to the backtracking tree and analyze a little bit about the time complexity. I think nobody would like to analyze it because for this number 2, it can have a duplicate. So this is basically an NP problem. I suggest do not analyze the complexity because you cannot, you cannot calculate it. I don't believe anybody can calculate. Maybe everybody have different answers. They have 2 to the power of a target, 2 to the power of a target times k. Yeah, but this is, I'm not sure if this is the right answer, because this number 2 can be included. If every number is unique, it is very clear, we know the backtracking, it is 2 to the power of n is n equals to target. But for this situation, this 2, 3, or 5, each number of them can be included. But for us, if we trim it a little bit, a lot of things can be trimmed. So it is basically 2 to the power of target times k, yeah. Thank you for watching. If you think this is helpful, please like and subscribe. I will upload more Leetcode problems like this. Bye.